Hi, today I will talk about a simple harmonic motion that can be abbreviated as SHM. Let's get to the definition at first. SHM is the motion that repeats itself at regular time intervals. Here is a demo. In this setup, I have a stand. As you can see, I have this stand on the base, and this stand is holding a spring. At the bottom of this spring is a block of mass m, for instance. What I can do is I can apply an upward force on this mass, and what we are all supposed to see is a repetitive motion. So once I apply this upward force F, this block would start moving up. At some point, the situation would be something like this, and at some later stage, what we would see is this block would actually start coming down, moving down, and eventually we may see something like this. So the block would move up, and then it would start moving down. As you can see, it actually came down at some point in the time. So this up, down motion is what we call simple harmonic motion in plain words. It's a motion that repeats itself at regular time intervals. That was just a demonstration of what actually happens in practical scenario. And now I would talk about the equations, the technical terms. As we have observed that the displacement of this block is initially up and then down, and in the future it would actually repeat this pattern. So up, down, so it's like up, down, something of that form. And the displacement of this block can be modeled by this equation right here. So x is the displacement of this mass. X means displacement, and x sub m is the amplitude. A cosine function is being used to capture this up and down motion of the block. Omega is angular frequency, t is the time, v is called the phase constant. Note that the argument of the cosine function, by argument of the cosine function, I mean omega t plus phi. So the argument of cosine function is omega t plus phi. This omega t plus phi is called phase. And omega, which is the angular frequency, can also be written as 2 pi f, and f is just the inverse of the period. So 2 pi f can in turn be written as 2 pi by capital T. Capital T is the period of oscillation. it is worth noting that omega is the angular frequency, f is just the frequency, and capital T is the period of oscillation. Next, I talk about the velocity. As you know, we can derive the velocity from the time derivative of the displacement. So we have the displacement right there. We can differentiate x in order to get the velocity. So if we differentiate this expression right here, we actually end up with the velocity. So v equals dx by dt. V equals so let's just differentiate this expression. If we do so, we actually get negative omega x sub m sine of omega t plus phi. So cosine, if we differentiate cosine, we get negative sine. And we also need to differentiate once what we have inside the parentheses. So if I differentiate this expression inside the parentheses, I actually get omega. So omega would show up in the front. Now that I have the velocity, I can differentiate velocity to get acceleration. So if I differentiate this expression, I actually get the acceleration. This is just a basic differentiation, and acceleration turned out to be minus omega squared x sub m cosine of omega t plus v. Note that this thing right here is the displacement x. So I can actually replace this expression by just x. So we have a and then minus omega squared, and this can be replaced by just x, which is the displacement of this block. A is equal to minus omega squared x. A is the acceleration, omega is the angular frequency, and x is the displacement. We just derived the relationship between the acceleration and the displacement. This is the governing equation for simple harmonic motion. I repeat, this is the governing equation for simple harmonic motion. In simple harmonic motion, the acceleration, which is this, is proportional to the displacement, which is that, but opposite in sign. We have the negative sign, and the these two quantities are related by the square of the angular frequency. These two quantities are related by the square of the angular frequency. That is pretty much it. In this tutorial, I have talked about the idea of simple harmonic motion. I started with the definition, and then here I had this demo. Here are the equations and the variables. Here is the governing equation for simple harmonic motion, and at the very bottom I have this governing equation explained in words. I hope you would find this tutorial helpful. Thank you.